Welcome to my channel. Please subscribe. Introduction to Object-Oriented Thinking and Object-Oriented Programming. Comparison with Procedural Programming. Object-Oriented Thinking (OOT) and Object-Oriented Programming (OOP) are two important concepts in computer science. OOT involves a way of thinking about the world in terms of objects and their interactions with each other. OOP is a programming paradigm based on OOT, where programs are designed and implemented using objects. In contrast, procedural programming is a programming paradigm where programs are built around procedures or functions that operate on data. The main difference between OOP and procedural programming lies in the way they approach problem solving. Procedural programming focuses on procedures or functions that operate on data, while OOP focuses on objects and their interactions with each other. In OOP, objects are self-contained entities that have their own data and behavior, and they communicate with each other through well-defined interfaces. Another key feature of OOP is inheritance, where objects can inherit properties and methods from other objects. This allows for code reuse and makes it easier to create and maintain large software systems. Compared to procedural programming, OOP has several advantages. It promotes modular and reusable code, making it easier to maintain and update software systems. It also allows for better organization and management of code, making it easier to debug and test. However, OOP also has some drawbacks. It can be more complex than procedural programming, requiring a greater understanding of programming concepts and design patterns. It can also be less efficient than procedural programming for certain types of tasks. In summary, object-oriented thinking and object-oriented programming offer a different approach to problem solving compared to procedural programming. While it may require more upfront effort and knowledge, OOP can lead to more modular, reusable, and maintainable code. Features of object-oriented paradigm. Merits and demerits of OO methodology. Object-oriented programming (OOP) is a programming paradigm that is based on the concept of objects. In OOP, an object is an instance of a class, which encapsulates data and the operations that can be performed on that data. One of the key features of OOP is inheritance, which allows for the creation of classes that are based on existing classes. This can lead to more efficient and modular code, as well as improved code reusability. Another important feature of OOP is polymorphism, which refers to the ability of objects to take on multiple forms. This is achieved through the use of interfaces and abstract classes, which allow for different objects to share common behavior while also having their own unique behavior. In addition, OOP emphasizes the use of encapsulation, which means that the implementation details of an object are hidden from the outside world. This helps to protect the integrity of the object and prevent unintended modifications. There are several benefits to using an object-oriented approach to programming. One of the main advantages is improved code organization and readability. OOP allows for the creation of modular, reusable code that can be easily maintained and updated. Additionally, OOP promotes code reuse, which can help to reduce development time and costs. Another benefit of OOP is the ability to create complex, real-world systems that accurately model the problem domain. However, there are also some potential drawbacks to using OOP. One issue is the complexity of the approach, which can make it more difficult for beginners to learn and understand. Additionally, OOP can be more resource-intensive than other programming paradigms, which can impact performance. Finally, OOP can be more challenging to implement in certain types of applications, such as those that require high levels of concurrency or real-time processing. Despite these potential drawbacks, the benefits of OOP have led to its widespread adoption in a variety of industries and applications. By leveraging the power of objects and encapsulation, developers can create more flexible, modular, and maintainable code that can adapt to changing requirements and scale with the needs of the organization.